Hey everyone, today we're going to be doing another question from Elements of the Programming Interviews in Python. This one is called Search First Key. This is a binary search problem. We're going to be finding the first occurrence of a value k in an array called A, and we're going to be returning its index. If it's not present, we're going to be returning a -1. So this is a slight variation on binary search, where we want a binary search, but we don't want to just find any random occurrence of this value. We want to find specifically the first one. Now, a very common mistake that you could make is, well, you're going to do binary search until you find a particular value, for example 5, and then you're going to stop and just search left until you find the first occurrence. Now, this is a mistake because if you have something like 1, 1, 1, 1, 1, on and on, a million ones, and you want to find 1, and if you manage to end your binary search on some 1 over here, you might end up going all the way over left, which reduces this time complexity to O of n. And the advantage of binary search is we want to get a time complexity of O of log n. So we want to take advantage of the fact that the array is sorted to find this value by subdividing this array. Now, if you're not comfortable with regular binary search, you should probably brush up on that. I'll put a link in the description. This is going to be a slight variation on binary search, where each time we find an occurrence of this value, we're simply going to update a results variable, and then we're going to continue doing a binary search. So no matter what, even if we find our value at the beginning of our binary search, we're going to complete our binary search until we've completely exhausted all our values. So let's see this in action. We'll start with declaring our left, right, and our result, which by default is going to be 0. It's going to be length of A minus 1, and it's going to be -1. We want our result to be by default -1 because if we never find any value, we're just going to return this -1. Our left and our right hold the slice of our candidate array. So we know that we are searching in A of left to right plus 1 each time. So the right index here is inclusive. And now we just go into our old-fashioned binary search. We'll say while left is less than or equal to right, we're going to say mid equals left plus right over 2. Now, one quick thing that you should know is that in languages where you do have an integer overflow, so if you have 32-bit integers or 64-bit integers, you might want to say mid equals left plus right minus left over 2. Otherwise, you might get an overflow error if you do left plus right. So this is something to watch out for. Thankfully in Python we don't have to worry about this, but this is something to keep in mind. Then we're going to say if A of mid is less than k, then what does that mean? That means our target, that the middle of our array is too small for our value, which means that we need to tighten our left boundary. So we're going to say left equals mid plus 1, because we know that mid cannot be part of our target array, so we increment it by 1. Otherwise, we're going to say, otherwise, if A mid is greater than k, we're going to do the same thing where we're going to tighten our right boundary. So we're going to say else right equals mid minus 1. Now in this else statement, in a classic binary search, you would say return mid. However, this mid might not be our actual solution. So instead, we're going to say result equals mid, and then we know that the first occurrence is going to have to be to the left of this mid. So we're once again going to tighten our right boundary. So we're going to say right equals mid minus 1. And then as we loop over this, every single time our search space is cut in half, which is what ensures our O of log n runtime. And once this search space has been exhausted, we're just going to simply say return result. And if we never set this mid, then we're just going to be stuck at this -1, which we initialized right on this line. Otherwise, we would have done an exhaustive binary search, each time updating our result to whatever the value was that we found. And now if we test our solution, we pass every single test case using our EPI judge, and we have concluded our search of first K problem. Hopefully you enjoyed this video. If you did, please like, comment, and subscribe. And if you'd like some personalized interview help, for example, mock interviews or interview prep mentorship, then fill out the Google Docs form in the description or visit our site and book an appointment. Thank you for watching and have a great day.